In the cold reaches of our solar system, far beyond Neptune, a tiny world orbits in silence. Pluto, once a proud ninth planet, then downgraded to a dwarf, has always been shrouded in mystery. Discovered in 1930 by Clyde Tombaugh, Pluto was the first object found in the Kuiper Belt, a vast region of icy bodies beyond Neptune. Its discovery was hailed as a major triumph in astronomy, completing the solar system as it was then known. But from the very beginning, Pluto was different. It was smaller than Earth's moon. Its orbit was wildly elliptical, even dipping inside Neptune's path for part of its 248-year journey around the Sun. For decades, we saw Pluto only as a fuzzy dot, a distant wanderer, an outcast among the planets. Then came 2006. In a controversial move, the International Astronomical Union reclassified Pluto as a dwarf planet. The world protested, scientists debated, children wrote angry letters to NASA. Pluto had been stripped of its status, but not its mystery. And then, silence. Until one mission changed everything. On July 14, 2015, NASA's New Horizons spacecraft flew by Pluto at 14 kilometers per second, capturing humanity's first close-up look at this icy enigma. What it found would astound the world. Pluto was not just a frozen ball in space. It was alive, with mountains, glaciers, a blue atmosphere, and possible signs of recent geological activity. What was once thought to be a dead rock was now a place of dynamic transformation. The mission revealed a frozen heart, a vast, icy plain named Sputnik Planitia, spanning more than 1,000 kilometers. Scientists had never seen anything like it. Pluto was no longer a footnote. It was a frontier. And the questions were just beginning. When New Horizons sent back its first images of Pluto, scientists expected a barren rock. What they got was a geological wonder. Towering ice mountains rise over 11,000 feet, made not of stone, but of water ice so cold it's harder than rock. Vast nitrogen plains ripple with patterns that hint at convection, where the surface slowly churns from below, like bubbling soup, but frozen. Some regions have fewer craters than expected, suggesting they're geologically young, perhaps just 10 million years old. But Pluto has no tidal forces to heat it, no nearby moon to stir its core. So, what's driving this activity? Beneath the icy shell, data hints at something shocking. A liquid water ocean, hidden for billions of years under frozen nitrogen and methane. On Earth, life thrives in oceans beneath ice, in places like Antarctica's Lake Vostok. Could Pluto, against all odds, support similar life deep below? And there's more. Pluto has an atmosphere. Thin, yes, but real. Hazy, bluish, and layered. As it nears the Sun on its long orbit, Pluto's surface ices vaporize, forming a transient atmosphere that collapses as it drifts away. A planet that breathes. But Pluto's atmosphere isn't just made of nitrogen and methane. There are complex hydrocarbons, compounds that, on Earth, are precursors to life. Some scientists now believe these chemicals are formed by ultraviolet sunlight interacting with Pluto's surface, a form of alien chemistry happening right now. These processes create tholins, dark, reddish compounds that paint Pluto in shades of crimson and black. Organic in nature, mysterious in origin. And yet Pluto is not alone. Its largest moon, Charon, is nearly half its size. Together, they form a binary system, locked in an eternal dance, each always showing the same face to the other. Charon, too, is scarred by canyons, cliffs, and strange surface markings, possibly caused by ancient subsurface activity or even oceanic eruptions. This isn't just one world with secrets, it's two. A system of frozen enigmas on the edge of our solar system, whispering of ancient histories and unknown futures. Pluto doesn't behave like the other planets, because it may not be from here. Its orbit is tilted, stretched, and unlike any of the classical planets, more like a comet than a world. For decades, astronomers have puzzled over this oddity. Some now believe Pluto didn't form where it currently resides, but was captured. In the early chaos of the solar system, icy bodies from far beyond Neptune collided, scattered, and migrated. Pluto may have once been part of the Kuiper Belt, a vast ring of frozen remnants, leftovers from the formation of the solar system. But even among Kuiper Belt objects, Pluto is strange. Its mass, density, and binary pairing with Charon suggest it survived a massive collision, or perhaps formed in a way we still don't fully understand. New Horizons data hints at complex layering in Pluto's geology, the kind seen in planets that have undergone intense internal heating and resurfacing. But how can such a small body generate enough energy? One idea. Pluto contains radioactive materials in its core, slowly decaying and providing warmth, enough to keep an ocean from freezing entirely. Another. Long ago, Pluto passed close to Neptune, and gravitational interactions may have torn it from its birthplace. There's even a theory, controversial but growing, that Pluto is an interstellar object, not born of our sun, but caught in its gravity. That would make Pluto a time capsule from another star system, a cosmic outsider, carrying chemistry not native to our solar neighborhood. And if that's true, what else could be hiding in the Kuiper Belt? What else have we mislabeled as debris, when it might actually be ancient messengers? Pluto's secrets may not just reveal the past of our solar system. They may hint at the structure of others. At the edge of everything, Pluto waits, a mystery frozen in time, whispering across the dark. Pluto may be cold, distant, and silent, but its story isn't over. In fact, some scientists believe Pluto's real importance is still ahead of us. As we look outward, beyond Neptune, Pluto may serve as a stepping stone, not just to the Kuiper Belt, but to the stars. Think about this. It's the first known world beyond Neptune to be explored. New Horizons changed everything, showing us that even frozen worlds can be complex, geologically active, and beautiful. Now, researchers talk of return missions, orbiters, landers, and even probes to drill beneath Pluto's crust in search of its underground ocean. Why? Because where there's water, there may be life. Pluto's suspected ocean is buried beneath kilometers of ice, protected from space radiation. In Earth's deep oceans, similar environments support entire ecosystems, without sunlight. Could life exist under Pluto's ice, not thriving, but surviving? If we find it there, we'll know life doesn't need warmth, or sunlight, or Earth. It just needs the right chemistry. That changes everything. But even if Pluto is lifeless, it may become something else entirely. A refueling station. Some long-term visions of space travel imagine humans mining Pluto and other icy bodies for water, oxygen, and hydrogen, building infrastructure at the edge of the solar system. And because Pluto's gravity is low, launching from it would be easier than from Earth, making it a perfect site for deep space missions. Terraforming Pluto? Not likely. But building bases there? Maybe. If humanity becomes a spacefaring civilization, Pluto won't be forgotten. It'll be part of the plan. A cold outpost, yes, but a vital one. As our eyes turn to exoplanets and other stars, Pluto reminds us, the smallest worlds may hold the biggest surprises. What seems dead may be dormant. What we dismiss as distant might just be the beginning of the next great journey. Pluto was once the proud 9th planet. Then, in 2006, it was downgraded, declared a dwarf planet by the International Astronomical Union. For many, that moment felt like a cosmic insult. School children were confused, scientists were divided, and Pluto became more than a distant world. It became a symbol. But why was Pluto demoted? The IAU said a planet must orbit the sun, be round from gravity, clear its orbit of other debris. Pluto failed that last test. Its orbit overlaps with other objects in the Kuiper Belt, meaning it's not gravitationally dominant. That rule, however, sparked global debate, because by that logic, Earth, Jupiter, and even Neptune would fail in certain zones. Some astronomers, including Alan Stern, head of New Horizons, argue the definition is flawed. They say we should define a planet by its geology, not just its orbit. Pluto has a complex atmosphere, weather patterns, organic chemistry, possible subsurface oceans, and active geology. How is that not a planet? Even more fascinating. Pluto has 5 moons, including Charon, which is nearly half its size. Some scientists call the Pluto-Charon system a binary planet. Two worlds locked in a gravitational embrace. Imagine that. A dwarf world with a satellite large enough to almost count as a second planet. The public hasn't let go either. Across the world, people still consider Pluto the ninth planet. T-shirts, stickers, and protest signs still say, "Pluto is a planet. Fight me." So who decides what's a planet? The truth is, we're still debating. New definitions are proposed. Some suggest over 100 planets in the solar system, including Pluto, Ceres, and Eris. Others warn that expanding the list will confuse people and weaken the meaning of planet. But maybe that's the point. Maybe Pluto teaches us that categories don't always fit nature, that the universe doesn't care about our definitions. It just is. And perhaps that's what makes Pluto truly powerful. It refuses to be boxed in, refuses to be small, refuses to be forgotten. Pluto is more than ice and rock. It's a story, one that's still unfolding, a symbol of how little we truly know. In 1930, Clyde Tombaugh gave us a new world. In 2015, New Horizons gave us a new vision. And now, in the 2020s, we face a choice. Will we see Pluto as a dead end, or the beginning of something bigger? Every time we look deeper into space, we find surprises. Water on moons, geysers on dwarf planets, magnetic fields in places we never expected. Pluto reminds us, labels don't matter. Exploration does. One tiny world forced us to rewrite textbooks, challenge assumptions, and ask deeper questions. Is Pluto a planet? Is there life beneath its crust? What else is waiting out there, in the dark? Maybe Pluto isn't the end of the solar system. Maybe. It's the key. The key to ancient history. The key to understanding formation itself. The key to the Kuiper Belt, and beyond. It's easy to think Pluto is small, forgotten, dismissed. But in truth, Pluto is vast, in mystery, in meaning, in potential. We used to end the solar system with Pluto. Now, we know it doesn't end there. So what do we call Pluto? A planet? A dwarf? A Kuiper body? Call it what you want. Just don't call it unimportant. Because in a universe of giants, Pluto reminds us that even the smallest worlds can change everything. This is Pluto's legacy, and we're only just beginning to understand it.